I am Cyrus James V. Sulit and I am going to discuss about the log periodic antenna. For the introduction, in telecommunication, a log periodic antenna is a broadband, multi-element, directional, narrow beam antenna that has impedance and radiation characteristics that are regularly repetitive as a logarithmic function of the excitation frequency. The individual components are often dipoles. The length and spacings of the elements of a log periodic antenna increase logarithmically from one end to another. So the key points here are it has high bandwidth and moderate directivity. So for the structure, a log periodic antenna has an array of dipole which has their length according to logarithmic scale. Log periodic antenna is basically a wideband antenna because it has many dipole elements which are of different length radiating different frequency. So the structure of log periodic antennas is shown in the right side. In this the dipole array are cross-connected to each other. The point of excitation. The single element is provided excitation via these cross-connection lines. Here, only one element has provided excitation and another element has no separate excitation. By varying the point of excitation, we can change the radiation pattern of log periodic antenna. For the radiation pattern of log periodic antenna is shown here. From the pattern, we can say that it has less directivity than other antennas like Yagi-Uda. But we can obtain wide frequency response than any other antenna. Here, the radiation pattern is shown at 12 MHz frequency. So the uses uh, is this antenna design is used where a wide range of frequencies is needed while still having moderate gain and directionality. It is sometimes used for a VHF or UHF television antenna. So LPDA or array log periodic dipole array with a coaxial feed. So this is typically 50 ohms or 75 ohms. And B is a crisscross open wire line for twin lead feed. So this is typically 300 ohms. So the history or origin of LPADs is why it need to be existed for broadband antennas. And where does it start? In the University of Illinois. And when? In the year 1955 to 1961. So log periodic dipole array with various connections. So the first is a dipole array. It is a dipole is a pair of oppositely charged electrodes that are so close together that the electric fields seems to form a single electric field rather than a field from two different electric poles. So the next one is the straight connection. Next is the crisscross connection. And lastly is the coaxial connection. So for the nodes, the length L sub n, location R sub n from apex, diameter is D sub n, and gap spacing S sub n of the dipole elements increase logarithmically as 1 over tau, where tau is a LPDA design parameter called the scale factor. For example, 1 over tau is equals to L sub n plus 1 over L sub n is equal R sub n plus 1 over R sub n equal to D sub n plus 1 over D sub n equal to S sub n plus 1 over S sub n. So another LPDA design parameter is the spacing factor sigma. Example, sigma is equals to R sub n plus 1 minus R sub n over 2L sub n plus 1. By drawing straight lines, through the ends of the dipole elements of the LPDA, we see that they intersect at a point called the apex and enclose an angle 2 alpha. Example, alpha is equals to tangent raised to negative 1 minus tau over 4 minus sigma. So typically 10 degrees is less than equal alpha, less than equal to 45 degrees with 0.95 less than equal to tau and less than equals to 0.7 where alpha and tau are inversely related. So the LPDA is a backfire array. In example, the maximum radiation occurs at the feed side or the small end of the antenna. For a compact LPDA, larger values of alpha or smaller tau are used. This leads to fewer dipole elements. A trade-off is larger variations in the input impedance and lower directivity or gain. Smaller values of alpha or larger tau, LPDA designs have more elements that are spaced more closely. This yields a larger LPDA. A benefit is that more elements fall in the active region, with the result being smaller variations in the input impedance and higher directivity or gain. For the applications, a log periodic antenna is used in a number of applications where a wide bandwidth is required, along with directivity and a modest level of gain. First is the UHF terrestrial TV. The television spectrum extends over a wide bandwidth, more than normal Yagi antennas. HF communications. Log periodic antenna arrays are often used in application where HF communications for diplomatic traffic. EMC measurements. EMC measurements require scans over a wide band of frequencies. Log periodic antennas can be used in this application. And lastly, other applications where log periodic antennas can be used. Any applications where directivity and a wide bandwidth are needed. So for the advantage and disadvantage, log periodic antennas are designed to work across a wide range of frequencies or a UHF. For the disadvantage, on lower frequencies, HF, VHF, a disadvantage of the log periodic dipole antenna or the LPDA is the number of elements needed, and therefore weight and wind load when installed outside. That is all for my report. Thank you.